Today is the time for some exercises, and I have exercises first for the chi-square test, which is the test for analysis of frequencies. And one thing that I want to mention about these exercises, specifically the exercises about the chi-square analysis, is that each of these questions or each of these exercise questions, they have a mistake, and that mistake has been deliberately introduced into those exercises during the solution of those exercises. So what you have to do is that you not just have to solve these exercises, although these are the solved examples, but you have to solve them on your own as well for the proper exercise. So you have to solve these exercises, and in addition to that, you have to identify the mistake and correct it. That is present in every exercise. And if there is no mistake in the exercise, then you can mention that there was no mistake in that specific question, in that specific exercise. So in this recorded lecture, I'm not going to point out the mistakes and I'm not going to correct them. Rather, I will discuss those mistakes and corrections during the question answer session. So until then, you should have solved these exercises, and you should have identified the mistakes, and you should have corrected those mistakes, right? So now, starting from the exercise number 1, the question number 1 is: a farmer stocks a pond with fingerlings of 5 fish species in following numbers. So what are these numbers? There are 400 for catla, 400 for labio, 400 for silver carp, 400 for common carp, and 400 for grass carp. So these are the numbers in which the fingerlings of five species have been stocked into a pond. So after 2 years of growth, the farmer harvests a sample of 250 fish from the same pond and observes different types of fish in following frequencies: 43 for catla, 47 for labio, 55 for silver carp, 56 for common carp, and 49 for grass carp, right? So these are the observed frequencies from a catch of 250 fish after 2 years of growth. So the question is, find out if the distribution of fish species in the pond homogeneous. So this is our calculation for the chi-square. This is our table for the chi-square calculation. So in this table, again, we have different columns. So the first column has the classes, the second column is the observed frequencies, which is 43 for catla, 47 for labio, 55 for silver carp, 56 for common carp, and 49 for grass carp. And then the next column is about the expected frequencies, which are 50 for catla, 50 for labio. So in fact, these are 50 for each of these fish. Then the next column is about the difference between the observed and expected frequencies, which is -7 for catla, -3 for labio, 5 for silver carp, 6 for the common carp, and -1 for the grass carp. Then the next column has the square of the difference between observed and expected frequencies, which is 49 for catla, 9 for labio, 25 for silver carp, 36 for common carp, and 1 for grass carp. And then the last column we have, and in the last column we have the square of the difference between observed and expected frequencies divided by the expected frequency of respective class. So first is the answer for catla, which is 0.98. So which is the square of the difference between observed and expected frequencies divided by the expected frequency of catla, which means 49 divided by 50, and the answer is 0.98. And then for the labio, the answer is 0.18. For silver carp, it is 0.5. For common carp, it is 0.72. And for grass carp, it is 0.02. Now we take the sum of these values, and this is our chi-square, which is 2.4. So this is the value of our chi-square. Now the table values of chi-square for this test are 9.488 at probability 0.05, 13.277 at probability 0.01, and 18.467 at probability 0.001. And the result is the distribution of fish species in the pond is not homogeneous. Chi-square 2.4, probability greater than 0.05. So this is our question number 1. So this is question number 2 for today for the chi-square exercises. So this question number 2 is that it is a similar example as the previous one, that a farmer stocks a pond with fingerling of 5 fish species in following numbers: 400 for catla, 600 for labio, 400 for silver carp, 500 for common carp, and 400 for grass carp. So after 2 years of growth, he harvests a sample of 250 fish from the pond and observes a different type of fish in following frequencies. So catla 35, labio 30 out of 250, silver carp 40, common carp 70, and grass carp 75 out of 250. So these are the observed frequencies. Now question is, find out if the distribution of fish species in the pond is homogeneous. So this is the table for the chi-square analysis for the chi-square test. So again, we have different columns. The first column is about the classes, which are catla, labio, silver carp, common carp, and grass carp. And then in the second column, we have the observed frequencies, which are 35, 30, 40, 70, and 75. And then in the next column, we have the expected frequencies, which are 50 for each of these classes of fishes. And then we have the difference of observed and expected frequencies, which is minus 15 for catla, minus 20 for labio, minus 10 for silver carp, 20 for common carp, and 25 for grass carp. And then in the next column, we have the square of the difference between observed and expected frequencies, which is 225 for catla, 400 for labio, 100 for silver carp, 400 for common carp, and 625 for grass carp. And then in the last column, we have the deviation. And what is deviation? The square of the difference between observed and expected frequencies is divided by the expected frequency of the respective class. So this is 225 divided by 50 for catla, and the answer is 4.5. Then for labio, it is 400 divided by 50, and the answer is 8. And then for silver carp, it is 100 divided by 50, and the answer is 2. And then for the common carp, it is 400 divided by 50, and the answer is 8. And for the grass carp, it is 625 divided by 50, and the answer is 12.5. So now we take the sum of these answers, and this is our chi-square value, which is 35. And the table values of chi-square for this test are 9.488 at probability 0.05, 13.277 at probability 0.01, 18.467 at probability 0.001. And we have the result. The distribution of fish species in the pond is very highly significantly different from homogeneity. So chi-square is equal to 35, probability less than 0.001. So this is our question number 2. Now our question number 3, and this question is also about fish. So a farmer grows silver carp in 3 types of culture systems, that is intensive, semi-intensive, and extensive. So he measures the condition factor for comparing the growth performance in 3 conditions, and he observed following. So in the pond number 1, which is intensive culture, the condition factor is 20 for less than 1, and it is 40 for greater than 1. Then in the pond number 2, which is the semi-intensive culture, the number of the fish with condition factor less than 1 is 30, and the number of fish for condition factor more than 1 is 50. And in pond number 3, which is about the extensive culture, the number of fish which have a condition factor less than 1 is 45, and the number of fish which have a condition factor greater than 1 are 25. So this is our scenario. Now the question is, find out if there is an association between culture system and condition factor of fish. So what we have to do here is we have to calculate the expected frequencies, and for the expected frequencies we have to do certain calculations which involve the row total and the column totals and the grand totals. So for pond 1, which is for the fish less than condition factor 1, so the first cell, the expected frequency is 27.14. The observed frequency for this cell is 20. For the next cell, which is for the fish with condition factor less than 1 in pond 2, the expected frequency is 36.19. Then in the third cell, this is for the fish which have condition factor less than 1 and they are present in pond 3, and their expected frequency is 31.67. And then in the next cell, we have fish which have condition factor more than 1 and they are present in pond 1. So the expected frequency is 32.86. Then in the next cell, we have fish which have condition factor greater than 1 and they're present in pond number 2. And their expected frequency is 43.81. And then in the next cell, we have fish, we have silver carps, which have condition factor greater than 1 and which are present in pond number 3. So the expected frequency is 38.33. So we have calculated the expected frequencies. And now is the time for the calculation of chi-square value. So we have our chi-square calculation table. So the first cell is about pond 1 and fish with condition factor less than 1. The observed frequency is 20. And rest of the observed frequencies are 30, 45, 40, 50, and 25. So these are for the different classes of fish in different ponds. And then we have the expected frequencies, which we calculated in the previous table. And then in the next column, we have the difference of observed and expected frequencies. So for the pond 1, the fishes which have condition factor less than 1, this difference is minus 7.14. And then for the fish with condition factor less than 1 in pond 2, the difference is minus 6.19. And then for the fish with condition factor less than 1 in pond number 3, this difference is 13.33. And then for the next cell, which is the fish with condition factor greater than 1 in pond number 1, the difference is 7.14. Then for the next cell, which is the fishes with condition factor greater than 1 in pond number 2, the difference is 6.19. And then in the next one, we have fishes with condition factor greater than 1, which are present in pond number 3, and the difference is 13.33. Now in the next column, we have square of this difference. So we have square of the difference values as 50.9796, 38.3161, 177.6889, 50.9796, 38.3161, and 177.6889. Then in the last column, we have the square of difference between observed and expected frequencies divided by the expected frequency of the respective class. So first we have 50.9796 divided by 27.14, which belongs to the class of fish which are condition factor less than 1 present in pond number 1. And the answer is 1.8784. Then we have the answer 1.0587, then 5.6106, then 1.5514, then 0.8746, and then 4.6358. And our calculation for the chi-square is 13.6096. And these are table values of chi-square for this test. At probability 0.05, the table value is 5.991. At probability 0.01, it is 9.210. At probability 0.001, it is 13.816. So the result is there is a very highly significant association between culture system and condition factor of fish. Chi-square is 15.61 and probability is less than 0.001. So this is the result. Now we have question number 4, and this question number 4 is about the same example that we were discussing, similar example that we were discussing in the previous question, that a farmer grows silver carp in 3 types of culture systems, that is intensive, pond 1, semi-intensive, pond 2, and extensive, pond number 3. And he measures the condition factor for comparing the growth performance in the 3 conditions. And these are the observations that he made. And there are 2 classes for the condition factor less than 1 and condition factor greater than 1. And these are the observed frequencies. Now the question is, find out if there is an association between culture system and condition factor of fish. These are the expected frequencies that we calculate by the formula which is used for the chi-square test of independence, the row total multiplied by column total divided by grand total, and this has to be done for each of these 6 cells. So the first cell, which is for the fish with condition factor less than 1 in pond 1, the expected frequency is 35.91. Then in the next cell, which is about the fish with condition factor less than 1 in pond 2, this expected frequency is 26.69. Then in the next cell, we have the fish with condition factor less than 1 present in pond number 3, and their row total is 75, their column total is 99, so they're multiplied and then their answer is divided by the grand total, which is 204, and the answer is 36.4. Then in the next cell, we have fish with condition factor greater than 1 present in pond number 1, and the answer is 38.09. And then in the next cell, we have fish with condition factor greater than 1 present in pond number 2, and the expected frequency is 28.31. And then in the next cell, we have fish with condition factor greater than 1 present in pond number 3, and the expected frequency is 38.6. So this is how we have calculated our expected frequencies for every cell. Now it is time for the analysis of chi-square, for the calculation of chi-square. So again, we have different columns in this table. The first column is about the different classes, different cells, and then the second column is about the observed frequencies, and then the third column is about the expected frequencies that we calculated in the previous table, and then the next column is about the difference between observed and expected frequencies, which is 35.91 minus 34 minus 35.91, and the answer is minus 1.91. And then for the next cell, which is the fish with condition factor less than 1 present in pond number 2, this is 25 minus 26.69, and the answer is minus 1.69. And then in the next cell, the answer is 3.6. And then in the next cell, the answer is 1.91, which is for the fish with condition factor greater than 1 present in pond number 1. And then we have 1.69, which is the difference between observed and expected frequency of the fish with condition factor greater than 1 present in pond number 2. And then we have minus 3.6, which is the difference between 35 and 38.6, and these are the observed and expected frequencies respectively of the fish with condition factor greater than 1 present in pond number 3. Now in the next column, we take the square of these differences between the observed and expected frequencies, and our answers are 3.6481, 2.8561, 12.96, 3.6481, 2.8561, and 12.96 for different classes. In the last column, we divide the square of difference between observed and expected frequencies by the expected frequency of the respective cell. So in the first cell, we have 3.6481 divided by 35.91, which are the values for fish with condition factor less than 1 present in pond number 1. And the answer is 0.1016. For the next cell, we have answer 0.1070, and then we have the answer 0.3560, and then the answer is 0.0958, and then the next answer is 0.1009, and the next answer is 0.3358. Now we take the sum of these values, and this will be our chi-square value, and the sum of these values is 1.0971, right? Now the table values of chi-square for this test are 5.991 at probability 0.05, 9.210 at probability 0.01, and 13.816 at probability 0.001. And the result is there is significant association between culture system and condition factor of fish. Chi-square 1.0971, probability greater than 0.05. Now we move on to another question, and this question is about the population densities. So the long-term population studies indicated that among the common rodent species found in a village, 35% are field rats, 27% are house rats, 20% are mole rats, and 18% are pygmy mouse. Farmers of that village started using a rodenticide, which is the chemical which is used to kill the rodents. So they started using a rodenticide to remove nuisance rodents from their fields and houses. During the start of the 6th year of this practice, a population study was performed to find out whether or not there is a change in the frequency distribution of rodents, and following results were obtained. Field rats 30, house rats 35, mole rats 65, pygmy mouse 15. So this is our state of affairs. Now the question is, find out if the frequency distribution of common rodent species in the village has changed in 5 years since the application of rodenticide, or in other words we can say, find out if the observed frequency follows the homogeneous pattern of distribution. So here we have our chi-square calculation table. The observed frequencies are 30, 35, 65, and 15. The expected frequencies are 50.75, 39.15, 29, 26.1 for pygmy mouse. Then we have the difference between observed and expected frequencies for our 4 classes. So first one is 30 minus 50.75, which is the observed and expected frequency of field rats, and the answer is minus 20.75. Then we have minus 4.15, which is the difference between the observed and expected frequency of house rats. Then we have 36, which is the difference between observed and expected frequency of mole rats. And then we have minus 11.1, which is the difference between observed and expected frequencies of pygmy mouse. Then we take the square of these differences, and these are our answers: 430.5625, 17.2225, and 1296, and then 123.21. And then in the last column we divide the square of difference between observed and expected frequency by the expected frequency. So this is 8.4840 for field rats, 0.4399 for house rats, 44.6897 for mole rats, and 4.7207 for pygmy mouse. And we take the sum of these values, which is our chi-square value, and this is 58.3342. Now the table values of chi-square for this test are 7.815 at probability 0.05, 11.345 at probability 0.01, and 16.266 at probability 0.001. And this is our result. There is a very highly significant difference in the frequency distribution of common rodent species in the village after the application of rodenticide. Chi-square 58.3342, probability less than 0.001. So now our question number 6, which is about the same example that we saw in question number 5, that the long-term population studies indicated that among the common rodent species found in a village, 35% are field rats, 27% are house rats, 20% are mole rats, and 18% are pygmy mouse. And the farmers of that village started using a rodenticide to remove nuisance rodents from their fields and houses. So during the start of the 6th year of this practice, a population study was performed to find out whether or not there is a change in the frequency distribution of rodents. And following results were obtained: 28 for field rats, 40 for house rats, 41 for mole rats, and 36 for pygmy mouse. So the question is, find out if the frequency distribution of common rodent species in the village has changed in 5 years since the application of rodenticide, or in other words, we can say that find out if the observed frequency follows the homogeneous pattern of distribution. So this is a table for the chi-square analysis. The second and third column, they have the observed and expected frequencies, and in the third column we have the difference between observed and expected frequencies, which is minus 11.75 for field rats, 7.85 for house rats, minus 9 for mole rats, and 12.9 for pygmy mouse. And then in the next column we take the square of the difference between observed and expected frequencies of respective classes. So this is 138.0625, which is the square of minus 11.75, which is the difference between observed and expected frequencies of field rats. Then we have 61.6225, which is the square of 7.85, which is the difference between observed and expected frequencies of house rats. Then we have 81, which is a square of minus 9, which is the difference between observed and expected frequencies of mole rats. Then we have 166.41, which is the square of difference between observed and expected frequencies of pygmy mouse. Then in the last column, we divide the square of difference between observed and expected frequencies by the expected frequencies. So this is 138.06.0625 divided by 50.75, which are the values for field rats, and the answer is 2.7204. Then in the next row, which is about the house rats, we divide 61.6225 by 39.15, and we get the answer 1.5740. And then the next answer is 2.7931, in which 81, which is the square of difference between the observed and expected frequencies of mole rats, is divided by 29. And then we have 6.3759, which is obtained after dividing 166.41 by 26.1, and these are the values for the pygmy mouse. So we take the sum of these four values, and that sum is our chi-square value, which is 13.4634 in this case. Now the table values of chi-square for this test are 7.815 at probability 0.05, 11.345 at probability 0.01, and 16.266 at probability 0.001. So coming to our result, there is a non-significant difference in the frequency distribution of common rodent species in the village after the application of rodenticide. So chi-square is 13.4634, and the probability is less than 0.01. So this is all about the questions for the chi-square analysis.